This is algebra 2. No, that's not the right. Back up. Come start the timer. Just trying to get to the right course. I'll be right with you all. Okay, this one. Okay. So greetings, scholars. Beautiful mind here. What this is just a homework session. So this evening we are to be doing section 9.5. I think that's the only thing that we have left on the binomial theorem. And this is a complementary homework set. So we'll just, let's hop into it. Let me see something. How many questions are in this? Not the same. So, okay. All right. We'll go through as many of these together as we can. So I'll just start with. Actually, I'll still jump around though, just in case we run short on time. Let me see. Give me a random number between 1 and 20. Okay. We'll start with question 15. And you have to bear with me. I'm like traveling as I create this, so you might hear other noises, and that's part of the reason why I'm talking so low. Okay. One other thing, let me make sure I'm sharing my screen because I just realized I was about to do the same thing and not share my screen. That was going to be attractive. Oh, I am sharing the screen. Okay, good. Just making sure. Because, oh, man. Anywho. Oh, wrong thing. Okay. All right. It's like a supplemental section. It's just something added on that we had to pull from another text for you all. Just, it's right there in Pearson. So again, this just complements. Okay. So find the coefficient of this in this binomial expansion. So we have something that allows us to jump straight to any term in a binomial expansion. So let me see. I'm gonna take some notes on this one. Come on. So here, I'll go about here. Just lost it. Oh well. This one. Yeah. Okay. So right now, I'm trying to do this without looking anything up. I might need to look one aspect up, but let me think for a moment. Oh, because I need to change the orientation. Becomes a little bit disruptive for these. Okay, let me see. Hang on. Okay, okay. Matter of fact, just for the sake of time, I'm just going to look it up just to be sure. So it's right here. Come on, get my help. Oh, everything's so slow. Come on. Come on. Let's refresh it. Okay, it's fine that it changed. Right here. There it is. So n choose n minus r, x to the r. Okay, that's fine. So I'll just use this new one. It's a little bit different than the one we were working a moment ago, but it's essentially the same thing. All right, let's try this one more. I'm gonna just get this because I need it to be a little bit smaller. Delete. Hopefully there's music playing and this video might not fly. But anywho, okay. So I think it was n choose n minus r. It was x to the r, y to the n minus r. All right, so that should be the term. Let me just check. I'm gonna go with it. We'll get it in just a moment. All right, so our n is 10 in this instance. All right, we're gonna have 10 choose. It's gonna be 10 minus 4. All right, this is gonna be x to the power of 4. Okay, and then our y in this instance is a 4 to the power of 10 minus 4. Okay. So if we start to simplify, 10 minus 4 is a 6. That's going to be 10 choose 6. That's going to be x to the 4. And then it should be what? 4 to the power of 6. Okay. So now the way I like to calculate 10 choose 6, the way I do it is I'll go 10 factorial divided by 6 factorial. But the top only goes out 6 spaces. So I'm not going all the way down to 1. I'm only going out, in this instance, I'm only going out 6 spaces. So what I mean by that is 10 times 9 times 8 times 7 times 6 times 5, right? 6 spaces. And then over 6 factorial. 6, 5, 4, 3, 2, 1. All right, that's the coefficient. 4 to the power of 6. I'm going to have to use my calculator for that one. Let's see, I got it here. Come on. So 4 to the power of 6, 4096. Okay. So we're going to have x to the 4 times 4096. Okay. So then we have cancellations. Like, for instance, this 6 cancels this, the 5s cancel. 4 times 2 is 8. And the 3 turns the 9 into a 3. Okay. So now at this point, we have 10 times 3 times 7 times 4096, x to the power 4. And then I'll just use my calculator for that as well. So that times 10 times 3 times 7. 860, 106. 860, 106 or 160? 160. 860, 160. X to the power 4. Okay. 860, 160, x to the power 4. Okay. So let's submit it and see how do we do. So then, and we were working, I think it was this one, full screen. Okay. So we got 860, 160, x to the power of 4. Let me check one other thing. It should be, let me check something here. Give an example. Yeah, n minus r. X to the power 4. Okay, so here, let's just do this. We'll be a little bit more direct. So the calculator can crunch combinations, right? So we're saying what? 10 choose 4. So if I hit, I'm going to do parentheses 10. I'm going to hit math. I think it's number, I got to find it. There it is. So over at probability number 3. So 10 choose, it should be 6. Times 4 to the power of 6. Okay. 80, 60, 80, 60, 81, 60. What am I missing? Oh, the coefficient. So much is okay. Yeah, sorry. They just wanted the coefficient. We put the whole term, right? So that's where the trouble is coming. So we just want just the coefficient. That was it. Okay. All right. I think we got the cobwebs off. Let's try another one. Let's get rid of that. And let's generate. Let's go to question 8. Right there. Pascal's triangle. Okay. Yeah, I think we should write this one out. I think, I mean, we could do Pascal's triangle. That's fine. Actually, I'm probably just going to do the binomial coefficient expansion. It's just faster for me. Come on, there we go. My device is like lagging day. It's like I'm having to click things 12 times before it registers. I'm gonna just leave this as a reference, just leave it kind of small. Now, Pascal's triangle, we talked about how to create it. I'm just gonna use the binomial coefficient. So if we want to expand this guy, right, we're gonna have what? 5, let me clean this up. 5, choose blank. I'm gonna leave it blank for now. The first coefficient is this x. We'll do it in blue. X to some power, and then the -5. -5 to a power, okay? Okay, so since we're doing the 5th row of Pascal's triangle, we need a total of 6 copies of this. Okay, so I'm just gonna duplicate this 6 times. Okay. So then like a plus, 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 and plus, okay? So now when we, in the binomial expansion, right? Let's start with the blue one, the first term. That's gonna count down. So it starts at 5, so it just goes 5, 4, 3, 2, 1, 0. Okay. And then the second term counts up. So it goes 0, 1, 2, 3, 4, and 5. Okay. And then the bottom portion of the binomial coefficient, it matches the orange. It matches the second. So that one counts up as well. So it goes 0, 1, 2, 3, 4, 5. Okay. Okay. So now when we go to calculate these coefficients, 5 choose 0, that's a 1. This guy is also a 1. N choose 1 is going to be n, so this guy here is a 5. This guy here is also a 5. Okay. And then 5 choose 2 is going to be what? 5 times 4 over 2 times 1. So that's a 10. So this one is 10. This one is also 10, right? So the coefficients are symmetric, right? The first and the last are the same. The second and second to last are the same. The third and third to last are the same, right? Okay. Okay. So let's keep going. So then in that first one, -5 to the power of 0 is, that's a 1. So it looks like it's just x to the power of 5 for that first one, right? It looks like this goes to a 1. This goes to a 1, okay? So we're gonna have what? Minus 5x to the power, nope. 5 times 5 is 25, so minus 25 x to the power of 4. The next one is 25 times 10. So that's 250 x to the power 3. So whenever we have like a negative in there, these are going to alternate. So it takes a little bit of effort to keep track of our signs, but I think we're okay. So the next one's going to be a minus 1250 x squared. The next one is a plus 625. Siri, never mind. Cancel. I just use my calculator. Oh my goodness. So let's do 5 to the power 5, 3125. So it should be 3125x. Let me see. And then the last one, I think it's just a minus 3125. Okay. So this is the result that we got. So what I'm going to do, I'll do a side by side.